Well, thank you everyone who's just joined us. Please feel free to ask any questions about today's webinar, Node.js V6 LTS Boron, either here in GoToWebinar or on Twitter with the hashtag #NeedToNode. All right. I think we've reached critical mass, and we can go ahead and get started. We have a very special webinar today for you with Rod Vagg, our Chief Node Officer, head of the Technical Steering Committee and the Core Technical Committee for Node.js with the Node.js Foundation, and sits on the board representing the Technical Steering Committee. So, there is no better person to share with us the latest and greatest of the Node.js LTS releases, the more enterprise releases, the more production releases. This is the second of these big releases, so it's very exciting to see the success of shipping LTS with Node.js go through a full cycle, and off we go into the next LTS. So it's been a great adventure with the first one. Let me hand it over to Rod, and I will see everybody in about 40 minutes for Q&A. Thank you.
Thanks, Dan, and thanks everyone for joining. I know it's a different time to usual. And that's you can blame Australia for that, that's fine. So I'm going to talk about version 6 LTS, as Dan mentioned. Now version 6 is not new, but version 6 LTS is new, and I'll explain how that works in a minute. But this presentation is mainly assuming that you are an LTS user. So most of the information here is about the journey between version 4 and version 6 LTS. But even if you're a user, you've been a user of 5 and 6, then there'll be some interesting things in here that you may not have known. So I encourage you to take some notes and fire some questions if you have any. I'm just going to skim over some things here, so with the hope of giving you a really high-level overview. And if you want me to delve in any deeper on specific things, I know there's some things in here that are of high importance to some people. Then please make a note. So let's try and get my presenter working. There it is. So as Dan said, I work with NodeSource. I'm the head of open source at NodeSource. I am the Node.js Foundation Technical Steering Committee Chair, and that I'm also a board member for that position. That doesn't mean I run things. It just means that I'm in a facilitation role. There are a lot more active people than me in the technical side of things, but I do have to keep an oversight there, just to know what's going on. I'm a long-time Node developer, become very passionate about Node after a long career with Java, still recovering from my Java addiction, I would call it. It's a very sad part of my life, but it's behind me now. So I'm going to introduce version 6 LTS now by talking about the release plan. This is a release plan that we developed prior to Node version 4, and we have refined it since then. So keep in mind as we're going along with this journey that a lot of these things are new. So this is the first time we've released a new LTS while having another one there. So we're still learning about these things. Things like the code name. We had one code name before, Argon, and now we've got another code name, Boron. So now we're discovering whether these code names actually help or not. And so there are a lot of things that are new here, and expect there to be adjustments along the way, as we've always been continually improving. But this is how it stands right now. So the Node release plan, it's based on the fact that we have this ongoing development in our master branch on GitHub, and that's unstable. That's while we keep all the tests passing and we consider it usable, it's not something we're prepared to ship as a release generally. So we pull things off onto these different branches and release them as versions. So every 6 months, in October and April of each year, we will cut a new major version. So that's incrementing that number, the main number, by 1, and then we call that current, and it lives for 6 months. So we have 6 monthly releases following one after the other. And as you can see, Node version 6 has existed since April 2016. And if you're on Node version 4, then you've even missed out on Node version 5, which lived for 6 months before that. So every second version, the version that is released in April each year, turns into an LTS. So long-term support, it means it's supported for an additional couple of years there. It's another 2.5 years, so that makes it for 3 years total. That period there is where things really stabilize and we focus on deployment and making sure that people have the assurance and the confidence to upgrade as we release new releases on that release line. So things really stabilize there, and we really target particularly enterprise users, particularly production deployments, particularly people with complex needs that don't want too much hassle from things changing underneath them. So we really prioritize that. So that's stability focused. Then what we actually do is we split that LTS period into 2 parts, where the final 12 months we call maintenance. Now, this is something we haven't got to yet for Node version 4, so I'm interested to see if it actually makes sense to delineate so starkly between active and maintenance, but we'll get there. We're currently Node version 0.10 and 0.12, we are calling them in maintenance mode right now. So this is where we really slow down and say only critical stability and critical security updates go in there in the final 12 months. It's still supported, it's still secure and safe to use, but things slow right down so we can move on to other things. So considering that, if you are an LTS user, you have this migration window between LTS versions. And the full extent of it is actually 18 months. So from the beginning of version 6 LTS, which is now, to when version 4 LTS ends, you have 18 months to plan a migration between the 2 versions. However, a recommended migration window is only 12 months long. The reason for that is that we expect there to be fading ecosystem support for the previous LTS. Particularly since we will also have a new LTS in version 8 coming along as that window ends there. So we expect version 4 to really power down, like we're seeing with version 0.10, even though 0.10 is very popular. Particularly the ecosystem has slowed down in supporting it, and the core developers have really moved on from that as well. So that's your optimal migration window, and I encourage you to think about how you can plan for your production migration between this window. So start testing out now and plan for a date that makes sense for you soon. This is an interesting strategy as well. This is possible. I consider this for the brave or perhaps the lazy. If you want to skip a whole LTS version, you could actually go from LTS version 4 all the way up to LTS version 8. So when we cut version 8 turn into LTS in October next year, you could actually still be on version 4 and skip a whole LTS version. This is not something I'd recommend, but it is there if you really have trouble with the migration windows, or you have really stubborn operations team. And this is how, at NodeSource, this is how we align with the node schedule for our nSolid product, which is your enterprise version of Node that we ship. So we follow the LTS window. And we're currently doing it for version 1 and the new version 2 of nSolid. And we're doing it for Node version 4 Argon and Node version 6 Boron. So you can actually download either the version 4 based version 1 or the version 6 based one. So if you're new to nSolid, I encourage you to give it a try and probably grab the version 2 nSolid based on Boron, and you'll be happy with that. So nSolid is another option for your enterprise deployments. So let's talk about what's new between Argon and Boron, between these code names. I'll just recap quickly on the code name business. So Argon, we chose that name for version 4. We decided we would go with the periodic table of elements, and we would do it alphabetically. So what we do is the LTS team narrows it down to a list of reasonable names that are pronounceable and don't have negative connotations or too many negative connotations. And then we put it up to the rest of the core team for a vote, and they choose which name they'd like. And Boron was the clear winner this time, and Argon was the last time. So next time it'll be based on C, so it'll be interesting to see what we come up with there. So what's different between Argon and Boron in terms of breaking API changes? So what do I mean by breaking? Let me explain this. We use semver as all users in the Node ecosystem should be using, because we're a very semver heavy ecosystem. That identifies breakage in backward compatibility of an API. So the version number tells you when something breaks. So that means that the first number there, which we call the major number, is actually the breaking number. So if that version increments, then there is something in the external API of a software release that breaks backward compatibility. So every 6 months, Node is incrementing that version. So that gives us, every 6 months, we can release things that might be breaking. So expect when that number increases, there will be breakages. However, we don't consider breakage a good thing, and this is not done lightly. It's not like, okay, we've got a chance now to break stuff. What can we break? It's totally it's mainly about refinement, API refinement, getting filing off some rough edges, and sometimes we get these things forced on us by external dependencies like V8. Often V8 will come with a new C++ API that we can't do anything about, and when we ship that, it'll break what we consider to be the Node external API, and we have no choice but to bump that major number. So that's why we've been a little bit slow in increasing V8. I might talk a bit later about strategies to improve that we're adopting now. But we don't take breakage lightly, and so you shouldn't expect, as we proceed, for breakage to happen very often in a way that will affect you. Mostly it'll be minor things that you probably won't even notice. So what happens is we keep this breakage, these semver major changes back on the master branch. So we land them. As we go on, they get landed on the master branch, and they may exist there for up to 6 months, and wait until we have a new semver major version to release. And then we release them. So right now we've got version 7 out, and we've had semver major tagged commits in there that have been sitting on our master branch for up to 6 months. And they're now just shipping, which is why when you look at the changelog, you'll see a lot of semver major changes. Any API breakage outside of that 6-monthly cycle is treated as a bug, and we revert that as quickly as possible. It does happen in that 6-monthly period. It does happen a bit more often than we'd like, and we try very hard to minimize that over time, but it does happen occasionally. We treat that very seriously though. The only caveat to that is that security fixes that require an API breakage are forced through as if they were a minor number change, so a feature improvement. And we saw that happen in both version 4 and 0.12 and 0.10 even, where we had to do some breakages that came with OpenSSL, with like removing certain ciphers or deprecating SSL version 3. They were technically breaking changes, but we had no choice but to push them in. So that may happen occasionally, and we'll make sure you get clear notice about that. So let's look at the breakdown. Between version 4 and 5, this was an artificially short window because we're just starting the process. It was only a few months, so there was very few breaking changes that were, and they're unlikely to cause problems for most users. These are really fairly trivial. An example of the triviality here was that the util.p function was removed. It had been deprecated for 6 years. It was introduced early on and then deprecated pretty quickly, and then left deprecated. And so we took the chance to clear up some of these really small things. So I'm pretty sure you haven't been using util.p, and that's the theme that you'll see in version 4 to version 5 breaking changes. Version 5 to 6, we did have 6 months period there. So there were 89 commits in total that we considered breaking. Mostly they were very insignificant though. So there was things like lots more explicit argument checking, and you'll see that again in version 7 now, and even in the changelog and the release notes. There's more explicit argument checking. If you're supposed to pass a function as a callback, it now checks there's a function as a callback in some functions. So things like that. So if you're using an API wrong, according to the docs, then some of these APIs may be a bit more strict. We also drop support for Windows Vista and drop support for OS X 10.7. So these are things that you need to be aware of as you're moving up to version 6 from version 4. All printed warnings now, anything that comes to standard error as a warning is now prefixed with, in parens, node colon PID, the process ID, and you'll get that on all the output, so you can actually now disambiguate if you've got lots of processes printing out to the same stream, you can see which ones are printing warnings. Error messages are now more consistent and informative across all internal modules, so grammar and all sorts of things have been made consistent, which raises an interesting point, which is that yes, we consider error messages and warnings to be part of the API, and therefore changes to them are breaking. We have some strategies to change that in the future with error codes, so that's coming in soon. But for now, the text is considered part of our API. There's a new buffer API. A lot of this was backported to version 4 as well. You may not be aware of it, but we have deprecated the buffer constructor. So even with new and without new, so new buffer or even just buffer, we deprecated that completely in the documentation. You won't get an error if you're using it, but the documentation suggests you not use it. And we've not got these new factory methods. We've got buffer.from, buffer.alloc, and buffer.unsafealloc, or alloc unsafe, sorry. And these are the new ways we recommend that you create new buffers with. If you are working with new buffers from scratch, a lot of people don't tend to make their own buffers, but if you are, then we recommend you migrate to these. Eventually, they will be. If you use the old constructor, then you'll get a warning message. But for now, it's just a gentle push. And we've also got the command line argument zero fill buffers, which is a feature that nsolid has had since the beginning, but we managed to backport some of that work that we did in nsolid into Node Core. So the Node Core changes now have this zero fill buffers flag, where you can any new buffer that's created by any module in your program will be zero filled by default. So there's lots of documentation about these changes out there in the wild, and you can look that up about the reasons for that. I won't go into that for now. Bunch of crypto and TLS modules. Module cleanup was done and modernized. This happens all the time because that whole landscape is moving very quickly. And interestingly, the TLS server has a client error event. And what has happened is that because HTTP server now has a client error event, this is a new feature, we have renamed TLS server client error to TLS client error. So now if you are, for example, listening on an HTTPS server, you can get both client error events and TLS client error events. So if you're listening to client error, you might want to also listen to TLS client error. These are non-fatal errors that happen on the client end. They won't kill your server, but they're sometimes worth listening to. Real path is an interesting story. fs.realpath, for finding the real path of a symbolic link on the file system. It caused a bit of drama during version 6, during the current period, so that 6-monthly period. What we did in version 6 is switched from a pure JavaScript implementation that had been around for a long time to a new native libuv version, which means that we are now using native system APIs, which is faster and cleaner and more consistent. However, we found at least 3 completely separate and distinct edge cases on Windows where it broke down and just didn't work at all. We didn't discover this until it was shipped and people started reporting it. And this is a funny one, not so funny for a lot of people, but there was a dramatic speed up in the API because we were using native versions really quick. What that speed up did is made a long-standing npm publish bug appear much more frequently. So this bug has existed for over 2 years. Shows up occasionally, people report it, you know, my publish didn't work. I've experienced it a couple of times, but you can't repeat it. Suddenly it was happening much more often, and people started saying don't use version 6 to npm publish. So the outcome of all of that was that we fixed the npm bug. The core team showed up and helped find and fix that. That's been fixed in npm version 2 and 3. And the Windows problems weren't. As much as we could do, we couldn't figure out how to do that. The libuv team couldn't come up with a great solution. So we mostly reverted those changes during version 6 current. So now we're back to the original state of a mostly JavaScript implementation. The API is slightly different, but we're back to the current state of play. So this is all to say that we ironed out those problems during the current period, and we expect this occasionally to happen, that things might come up that we don't have tests for because the Node ecosystem is so huge and people use Node in such diverse ways that we just don't know what people are doing with it, and these bugs come up when people start using it. We expand our test suite and move forward. But we're going into now this LTS period with this stuff ironed out, and mostly ironed out anyway. We expect it to be very stable for people. We're not just throwing a new version at you and testing on you. It has been tested for 6 months now. More interestingly, let's look at feature additions. So that was breaking API changes, highlights of things you should look out for. As you can see, there's not that many, but some feature additions that we added in version 6, jumping from version 4. So back to Semver, as I said, it identifies introduction of new features as well that don't break backward compatibility. So that's the middle number there, and that middle number increments every time we add something new that's external. So anytime we change an API, anytime we add something to an API or add a new API, we increment that middle number. And that's how we got to version 6.9. So the LTS Boron starts at 6.9. So we've had 8 releases that have added new things, and then this is the 9th, and now we expect that number to not move very much at all. It will move a bit, but it'll slow right down because we don't need to add new features very much in version 6. Node still embraces small core, so you don't need to be afraid of us just throwing lots of stuff in there. Major feature additions are rare, and most Semver minor changes are really uninteresting. So it's not like we added 8 huge features. It's that we had 8 releases where we added things that we, on a coin toss, we would consider a new feature. How we do this is that on the master branch, we generally pull in anything that's not Semver major. So that includes Semver minor and Semver patch commits into the current release cycle. So things that were added, a bit more activity than breaking changes between version 4 and 5. We marked 67 commits of Semver minor for that cycle during the version 5 release cycle. We introduced a couple of interesting debugging and inspection APIs, including the --prof--process command line argument for processing V8's --prof output. So V8 has a built-in profiler. It spits out really verbose and horrible output. V8 also has their own little JavaScript thing that it's called a tick processor that will process that data. We now bundle that, and you can run --prof process to run that against one of these output files from V8 Profiler. And that's really interesting output. I'd actually encourage you to go and play with that one because you might find some interesting stuff there. There's a new API internally for getting information about the V8 heap spaces. There's a bunch of heap spaces that it maintains, and you can watch that evolve over time in real time. And there's a couple other things in there that are to do with insight, tracing, and debugging. We introduced a new process warning API, and this is a big one. I think you should check this out because it's something you can use in userland to do interesting things with warnings, and you can also consume from core, which is emitting warnings itself. So there's an emit warning API that you can use to emit warning events in your process globally, and you can also consume them with the warning event on the process object. And then there's a bunch of command line arguments. For example, there's 2 of them there: no warnings and trace warnings. So these warning events are actually errors, like the error objects, like the error event, but they're non-fatal, and that you can get a stack trace from them. So if a warning is coming out, such as a deprecation warning, like you're using an API that's been deprecated, you can even trace that and look at the stack trace and find out where that's coming from in your application or in one of your dependencies. So this should be really helpful in that migration path of figuring out where those things are that are going to eventually be removed from Node that you need to move on from. So have a look at that API. It's in the API docs. We also introduced a event names method on event emitters. And that will give you an array of events that currently have registered listeners. People have been doing this for a while by accessing the internals of event emitter. It's not safe, so we have provided an external API for it. Very helpful. Should be good at some interesting performance optimizations for people. There's a lot of reasons people look for event names, and you can now do it with an official API. We added a fs.makeDirTemp method after a bunch of debate, but we decided eventually to add this to core. You can do this with modules from NPM right now, but we added it in core because there's a bunch of system level APIs that we can make use of to do this in a atomic and safe and fast way. So you can now call this. It calls down into libuv, which calls the system, so either on Linux or Windows or OS X, and it'll make you a temporary directory that is safe. So it's not a duplicate directory. It's a new directory, guaranteed to be new, and it's done really quickly. So it's a better API to use than the JavaScript implementations that people are using. And a bunch of little things like HTTP status code 451 was introduced, that's just a string unavailable for legal reasons, which was added to the HTTP spec recently. Some minor things were added to buffer. You can do some byte swapping now for endianness changing for if you're doing decoding of buffer streams. And also a last index of method was introduced to mirror the index of method, so you can search buffers starting from the end. So there was also in between 5 and 6 we added a CPU usage API, so you can now get CPU usage for the current process, and that fetches both user and system load for the current process, how much you're using. And we also added a preserve symlinks command line argument for resolving and caching module paths. This is another interesting one, a little bit like FS real path, where we added this as the default behavior in Node version 6. But we discovered that there were some interesting ways people were using Node where this broke down for them. It either broke down or just introduced really bad performance regressions for them. So when you are loading a module, you get the dir name and file name that tell you where that module is. And it also helps you to do relative location loading for dependency modules. So when you do require, it's based on where that directory is thought to be. So that actually uses the real path of your file. So if you make a symlink for your module file or even directory and you're doing some requiring, it will traverse into that real path and give it the real path in that dir name and file name thing. That was what we added in version 6. We decided on balance to revert that back to default behavior and introduce this command line argument instead. So you can now use this new behavior. A lot of people have been asking for this. And we're considering ways that we might change the behavior in future because we'd really prefer it to be the symlink path rather than real path. But since it's breaking in so many cases, we decided to go with this command line argument. You can now, when you do a util inspect or console log and it contains a large array, instead of printing the whole thing out, it'll now truncate it. So it'll tell you we've printed out only a small part of it because it's so big, which is nice so you don't get your console overtaken. This is similar to how browsers do it. We introduced a crypto.timingSafeEqual method, and this is a good one to understand. It's for constant time equality checking. It works similar to assert.equal, but it doesn't throw, I don't think. But you can now compare two strings or buffers and get a true or false. Are they the same? And do it in a way that is consistent. It has a constant time, no matter how the length of the strings. So what that means is that you can't do external timing attacks to discover secrets that you might have internally. If you're comparing to a secret key, for example, it's possible sometimes to do a timing attack on the comparison to figure out how quick it's taking and work out that key from some clever heuristics that people tend to use for timing attacks. So if you're comparing secrets, then you probably should use this API. Promises. This is a surprisingly big deal for a lot of people, but a lot of people like this feature. When you have a promise, a native promise, a V8 promise, and a rejection occurs on that promise, but there's no handler to receive it, no rejection handler, and none is attached within the same event loop tick, you will get a unhandled rejection event. In version 6, we introduced a warning that is printed to the console now. So if you have an unhandled rejection, you get this warning printed out. So you've had an error somewhere, a promise somewhere has swallowed it, and there is not a handler anywhere to receive it, and it's just gone missing. It's one of the drawbacks of using promises. It's really easy to ignore errors. So if that's happening, you will now get a event printed to console error. Sorry, to standard error, which you can turn off if you really want to with a command line argument, but I don't recommend that you do. And this is a really big one. This is the biggest one that people are most excited about. We introduced experimental support for the V8 inspector protocol. What this means is the Chromium team extracted this thing from Blink, and it's now going into V8. and we have got part of it in Node Core now, and it allows Node, it allows V8 now to expose this protocol called V8 Inspector, which Chromium can talk. So you can now attach Chrome DevTools to a Node process by using this protocol. Use the -- inspect flag, and it exposes it and tells you how to connect. And then you can do pretty much the same things that you do to JavaScript in Chrome as you can for this external Node process. So you can do some really cool stuff in there. I encourage you to experiment with that. There's been a bunch of posts on the web about it. I recommend Paul Irish's post on Medium when it was first released. He runs through some of the high-level features. But it's not just Chrome. It's not just about the Google team. We actually expect to see a bunch of other editors and development environments adopt the same thing. So Visual Studio Code can already do this. We expect WebStorm and others to be able to do it. There's some command line utilities that can even talk this now. So this is currently considered experimental, so it's not heavily documented, but we expect it to become official because it's going so well within the next couple of versions of Node. Some exciting things for JavaScript feature junkies. The V8 changes between Argon and Boron. There's a few changes here. Mostly there's a lot of performance improvement, which is great that we are now back on the performance track with our JavaScript engines. We seem to have got over this hump where it's all about features, features, features. What percentage of ES6 can we implement? Because ES6 is mostly implemented now across the major browsers, we're now actually concentrating on the performance of some of those features. So we're back to a little bit of balance now in between adding features and doing performance. So this is great news for Node users. The benchmarking working group is now doing real-time benchmarks. So every night they benchmark the Node branches, main Node branches, and publish the results to benchmarking.nodejs.org. It's not comprehensive yet, but that will expand over time. But overall, the metrics that we care about are heading in the right direction. This is good news for Node users, good news for Core as well. Overall, if you're using Node 0.10 now and you jump to version 6, you should experience a dramatic speed up in your applications if you are performance constrained now. ES6, this is what people really want to hear. So version 4 LTS, we had around 52% ES6 feature complete coverage. Node version 6 LTS, we get up to 97%. So we've got most of ES6 now, bar a couple of things. We're pretty much there for ES6. You can look at Kangax's compatibility table. That's the canonical source for these tests. Or there's a new site called node.green, and it'll show you some information there. And it actually shows you what you can do with feature flags as well. So if you enable Harmony flags on the command line, you can get access to some pre-release goodies in V8. So that's some sites to look up. So let's go through some of these V8 changes. This is an interesting one. It seems minor, but it can be a big deal for debugging, which is that a function is now named if it can be inferred. So normally when you have an anonymous function, you don't give it a name, so you don't say function foo and then define the function. It doesn't get a name. But now if you assign it to a variable or some other situations where you assign it to things that have a name, it infers the name. So that means that when you have stack traces and you do some debugging, you can actually print out more descriptive names. And our normal advice is to always name your functions. It helps dramatically with debugging and performance inspection. This does help in that respect by doing some automatic naming. You can now do destructuring natively in Node. This is a very popular feature, particularly when people are playing with features like imports. So you can now assign multiple variables to and extract them from a complex object or array. Have a look at MDN for how destructuring works and see if that works for you. REST parameters. This is something I actually missed from C programming, where you can say this argument has these. This function has these arguments, and then I want this last one to be an array of all the rest of the arguments. So that's what REST parameters mean. You get an array with anything else that's passed there. So you add the ... then a name, and that will turn into a proper array, not a crazy arguments object, a proper array. Spread operator is a little bit like the reverse of REST parameters, where you can expand, you can spread an array when you are using it, when you're referring to it. So instead of just passing an array to a function or using crazy call or apply, you can now spread that array and have it expanded into multiple variables. So it's a little bit like destructuring, a little bit reverse of REST parameters. And it even works within arrays themselves, so you don't need to do concatenation in some situations now. It'll just expand them automatically, like that bottom example. Default function parameters. Potentially makes an API more confusing, but can be useful. If you want to have a method that takes an optional number of arguments, you can apply defaults. That will be applied if the caller doesn't give that argument. Array includes, finally, we don't have to do array.index of and compare it to -1. You can now just call includes and you'll get a boolean. This is great news. Something that really needed to be added. There's some introspection and interception features now in Node version 6 LTS, so proxies are in there to do some crazy API proxying. There's also the reflect API to do some internal introspection. You can dig into that in MDM. I'm not going to go into details on that. And lastly, I'll just quickly run through some NPM changes because Node version 4 LTS Argon ships with Node NPM version 2. It still ships with it, and it will continue to ship with it for the foreseeable future unless something dramatic happens to NPM and they say we're not supporting it anymore or something. But they've called version 2 an LTS, so we're shipping that, and you get consistent behavior every time with version 4. But Node version 6 now ships with NPM version 3, even though version 4 has just gone gold. We're shipping it with version 3 because we know it's fairly stable, and it will continue to ship with version 3 as long as we can, which is hopefully the whole life of it, but we'll see. And you need to be aware of this because there's some fairly dramatic changes. It was actually a really big jump between version 2 and 3. And there were a couple of major things. The first one is that the package trees, install trees, are now very flat, much more flat than they were before. So they're actually called, they're maximally flattened. So as flat as they can be, which is great for Windows because Windows has path length character limits. So now it's flattened. Windows users should be able to install most things without having errors about not being able to fit in package name paths. Which is potentially also more friendly for browser packaging, depending on how you're packaging. If you're not using a fancy Webpack or Browserify, you can do some interesting things and make some assumptions about locations. There's also aggressive deduplication of packages across your tree, so it'll look at semver ranges and figure out how it can compromise and have less duplicate packages there, which is less disk, also less tree confusion as well. You've got mostly single versions of packages unless it can't resolve conflicts. There's also NPM shrink wrap improvements, which is actually a big deal for anyone that's using shrink wrap in production. This is something you need to be aware of. There's lots of bug fixes. It's smarter. It now updates with --save and the variants of save. When you do an npm install --save, it'll update your shrink wrap as well. But overall, what this means is the behavior of shrink wrap has changed somewhat since version 2. If you're using shrink wrap, you really need to test your deployments to make sure that they are consistent with the behavior changes. And there's a couple of minor things. There's a progress bar in version 3, which is only shown by default. So that's all you see. You don't see the normal output. You can change that if you want to. And also peer dependencies, if you're using them, probably shouldn't be. They're not installed by default automatically now, it only shows a warning. Basically, peer dependencies is considered a bit of a failed experiment, so we're moving on from peer dependencies. So you should consider moving on. And look, that's it from me. That's my roundup of Node changes, and I think I went a little bit long, but hopefully we've got some time for a couple of questions.
Excellent. All right. Thank you, Rod. That was very interesting. So, quick reminder as we get into questions. I already got quite a few, but please feel free to use GoToWebinar or tweet at NodeSource with the hashtag #NeedToNode. We're monitoring both. So first off, straight up the middle with ES7. will V6, the V6 release line, be updated to the version of V8 that supports async await?
No. I think it actually. I don't think it's even there on the command line. You can access a bunch of new features with command line arguments, so dash harmony dash something, and async await was enabled a while ago on V8. I don't, off the top of my head, I don't think we quite got there on V8, but you can actually look if you go node and dash V8 dash options. It should actually print out a bunch of options that you can pass to node that go directly to V8, and a bunch of those are harmony. And you'll see some of the things that you can enable. I don't think async await is in there. Async await is also not in version 7 of Node, which was released today. However, it is enabled by default on V8 version 5.5, which is the next version of V8. And given the way now we are trying to upgrade V8 within the current cycle, as long as we don't break the C++ API, if we can do that, for this next version of V8, we may be seeing async await enabled by default within the version 7 release timeframe. And if not, then because maybe they've changed something in the API that forces us to hold it off. If we can't do it, we'll try hard. I know there will be people out there that will try very hard to make it work. Right. But if there's some reason we can't, then it'll be there in version 8 for sure.
Right. I think there's a meta question in there. Michael asks, about async await. You touched on it there, Rod. We won't see the slipstream of V8 changes, in the V6 release. So yep. I believe Michael's heard, that the core team's interested in potentially shifting to a more aggressive stance. Now that we have our arms around the APIs a little bit more, the APIs are stabilizing. We're collaborating more with the V8 yep. team.
That's true. We've got a great collaboration with Google. Google are now a heavy consumer of Node through Google Cloud Platform. So they're caring about Node. The Google Cloud Platform team now is starting to intertwine with the V8 team even, and so they're collaborating on timelines. They're collaborating on APIs. We've seen the C++ API stabilize dramatically over the past year, and that's been one of the biggest things for Node. And so our new policy is that if we can upgrade V8 without breaking the API or the ABI as well, so application binary interface, if we can, which means basically if we can upgrade V8 and not make you recompile your native add-ons, then we'll do it. And we did it once during version 6, during the current period, and that was our test one, and we pulled it off. So native add-ons worked fine. There was a little bit of rewriting we had to do, a little bit of patching of V8 we had to do. We would expect that again, but if it's minimal enough and it doesn't hurt too much for us to do, it doesn't introduce too much risk, then we'll do it in version 7. And we may even have multiple versions of V8 come in during the version 7 current cycle, and then the same during version 8. But we will stop if it becomes too difficult to do. So it's not a guarantee. It's a guarantee that we'll try.
Right on. I think you may have touched on this, but a question here about the how would you compare the performance and scalability between each version of Node? And I imagine V4 and V6 LTS, and maybe back to 10.
Look, there's also another component in that, which is stability. When you're comparing them, if you start with version 10, version 10's been around for a long time. It's considered very stable. A lot of people can't let go of it, and they won't let go of it, which I don't recommend because it's ceasing support this month. It was pretty good, but there was a bunch of things where there still is a bunch of things there where it's just not stable. And I've done some over time benchmarking and memory testing of the different versions, and version 0.10 is actually really hard to keep going without encountering these random errors that happen occasionally. So we've actually increased the stability of Node processors across the versions, and that's great for scalability. 0.12, there's not that many people on 0.12, thankfully, and most people that jump there also jump to version 4. We can almost write off 0.12, although it's still supported till the end of this year. Performance-wise, there's a bunch of things that have gone in between version 4 and version 6, both in that we've done in Node, but also V8 have done. So you're not going to see major jumps in performance, and it will totally depend on what you're doing, but you will see some increases in performance. And an example of that is the promise API. When V8 introduced promises in natively, and you got that in version 4, the performance is really bad, and it's the kind of thing you just wouldn't use it if you cared about performance, and you just use Bluebird or something else. We're getting to the point now with promises where performance of the native ones are starting to be acceptable for most average cases of promises. And so it's those kinds of things we're seeing increasing, where they are now going back and optimizing some of the things they've added. So it depends on what you're using in your application, what language features you're using, what types of things you're doing, and that's something you have to prefix with any time you talk about performance in Node. But you will see a performance increase in your application. There's very few cases where there will be performance regressions, thankfully. So every time we do something in core that we know impacts performance, we try and make it up in other areas. We try and trade off, because we know people value Node for performance. It's one of the key tick boxes that people have for Node.
So the follow-on question from Otto. Can you tell us how Core deals with V8 physically? Does Core manage a fork of V8, or is it running V8 as is?
This is an evolving thing. Right now, the state of play is that we manage effectively a fork internally in branch. So we take V8 from upstream and we dump it into the Node repository as a commit, and every upgrade is commit. We now have a much more fluid cycle in Core, where we actually maintain a separate branch for the ongoing V8 versions that are not stable yet. So that's all even in Core, and people are experimenting with that and getting ready for that. So that's constantly happening. Sorry, my presentation is gone.
Oh, no.
There we go. Where was I? V8, yes. So the challenge, though, is that the V8 team move on from their old versions when they're done with them, but we don't. We now, with version 4 and version 6, even back to version 0.10, which is maintaining a version of V8 that's like nearly 3 years old, I think. V8 team have moved on from that so long ago. When they move on to a new stable, they just ditch the old one and it's gone. So how we manage that at the moment is all in branch, but we have been talking about strategies for doing it, maintaining a separate fork. We had floating patches already now, so if we can backport bug fixes, or we find our own, or security problems, we do it over the top of what we have in Node Core. But we have a collaboration now with V8 where the V8 team can actually run the Node tests in their own CI infrastructure, and we can run the V8 tests in our infrastructure. So we've got this dual collaboration thing going on. And they've made an offer that if it helps us to maintain older versions for a bit longer in their infrastructure, then they can do that for us. But I'm not sure that's going to work out in the long term because of the way they rapidly evolve. So I suspect we'll end up maintaining a separate fork and keeping that alive there. But right now, it's effectively a fork. It's just inside the Node repo.
Great. So I'm going to ask folks to hold their questions. I think I might have room for one more. I can't guarantee I'll get it in. The question that has to be asked, Rod, will Node.js ship with the Yarn package manager?
I think this was asked in an issue on the Node repository. I think it was a matter of days, like a couple of days after Yarn shipped. The answer is no, not right now. It's not going to happen. Yarn is a bit too immature to even make that call. Another problem with Yarn is it's actually quite big. It's quite a hefty code base. If it could be minimized, then it might stand a chance, but right now it's just not going to happen. and if it did happen, it would be a very gradual, slow thing. I don't see any, logical reason why it couldn't happen, except that we consider, shipping NPM is almost part of our API. So that's why we keep NPM version stable as we can, and they're doing a similar thing, keeping it stable across their major versions. So we want users to have that stability and seamlessness, and switching package managers introduces challenges there, but those challenges are not insurmountable. So watch this space, but there's absolutely no plans right now. It's just a matter of is it possible, and it doesn't make any sense right now. No and no, but maybe that'll change. That's really vague, but that's like the truth is it's vague.
Right.
There are no absolutes now with Node core development, really.
Right on. So final question. We had you touched on briefly what is coming in Node v7. Do you have any insight looking ahead to the next big LTS V8, the V8, the version 8 release of Node.js is going to be a fun one. So what do we have to expect next October on V7?
I expect there to be a code name that starts with C. Look, it's actually we don't maintain roadmaps now. Like roadmaps are just not compatible with the open governance model we have. So we don't have a clear roadmap. There are a few things to look at. So there's a few things that we have marked as experimental that we expect to firm up. One of them is V8 Inspector, that protocol. When we first introduced it, we were very cautious and was like, okay, this can exist in the current branch, but we may remove it before LTS. We didn't. It's gone down very well. It's been very popular, and people are embracing it, and other debuggers are embracing it. So I expect that to be not experimental very soon, which could mean that the old debugger is deprecated. Also, async wrap, now known as async hooks, will be finalized and properly made final at some point in version 7, and then it'll be available in version 8. That's a great inspection API that our own Trevor Norris is working on. You can use that now, even in version 4. There's features in there as well for it. It's just undocumented because it's unstable. Another one is the new URL parser, URL object. This is now bringing Node's URL parsing and handling up to scratch with the WhatWG spec that is included in all major browsers now. So Node had a URL parser that was pretty early. Now it's out of sync with what browsers are doing, so we're introducing this new one. It's in version 7 now. It's tagged as experimental. But if you require URL and then go dot all caps URL, you'll get this new URL parser that's sort of a mirror of the old URL parser, but it's the same, pretty much the same as what you get in the browser. We may find a path to deprecating the old one and introducing this one, but that's going to be extremely painful. But that one will probably become an official API at least at some point soon. And there's a bunch of other small experimental things. I would expect there to be new error codes coming out with all errors now, so you can actually reference codes rather than parsing the error strings, which people do, and a few other little things that are coming in. And the biggest things will be the V8 features, I'm sure. They're going to evolve over time. Who knows what we'll get? It's really hard to predict at this stage what V8 will give us by version 8. So I know that's not a great answer, but the fact is that the delta between version 6 and version 7 right now is not very big, and that's the way you need to expect Node development to happen. Whenever we introduce new features that are not breaking, we land them in that current period, so they're always coming out. So watch version 7, and you'll see new things coming out that will be there for you when you get to version 8 LTS. And then the breaking changes, they're always very minor, but they'll be held off and they'll come out when we cut version 8. They're not going to be that big like the version 7 ones now. They're actually not that huge, these breaking API changes, and they'll come out. So really, my advice is, if you want to know what's going to be in version 8 LTS, just watch the release notes for version 7 and then version 8, and you'll see pretty much exactly what's going to be in version 8 LTS.
So what are the chances of a V8 version 8 V8 version 8 in Node.js version 8?
Yeah, and maybe our code name will be Chromium. I think there's very little chance of that version 8 V8 being in there, but it's gonna be crazy because already now we struggle with people capitalizing the V or lowercasing the V, and it's already confusing when we refer to version numbers. It's gonna be very difficult. I don't think we'll be skipping version numbers, but that is a possibility, like Windows did. Who knows?
All right. Well, thanks everybody for joining us. Thank you, Rod, for a very insightful overview of Node.js v6 LTS Boron, and look forward to having you back on again soon. It was a year, and so definitely see you again a year from now. Thank you, everybody. Take care. Bye-bye.